In this video, we're going to go through all the version A problems of the sample final exam. For number one here, what I would recommend first is do a little rewriting on this one and also put an identity if it applies. So for this first one, we have the one is fine and tangent. I don't need to use an identity for this one. However, I think it's be better if we write it like this. So instead of this squared notation, we're going to put tangent pi over 6 all in parentheses, and then we're going to square that whole result. Now this next one, I'm going to put in a sign. So cosecant is the same thing as 1 over sine, but you got to be careful here because there's a square there, which means we have to put a square in this one. So don't forget about the square. If there's a square in the original one, there's going to be a square also when you apply the identity here. Now we're just going to use a unit circle to get the values of these. So pi over 6 would be, it's like 30 degrees, first quadrant. In order to find a tangent, when we look at the unit circle, it's the y value over the x value. So I'm going to take the y value over the x value there. So in this case, what you would have going on there is you would have a 1/2 divided by square root of 3 over 2. So in a way, you get that. And so if you do that part off of the unit circle, you're actually going to get 1 over square root of 3. So we get 1/2. So here's what it looks like. I'll do this off to the side here. We really have 1/2 over the square root of 3 of 2, over the square root of 3 over 2. This is the y value from the unit circle, and this is the x value there at 30 degrees. That's how we're getting those values. When you flip and multiply, we get this, 1 over root 3. Now, we don't have to worry about rationalizing it here because we're just going to square it in the next step, and so that radical is going to go away anyway. So there's no need to rationalize this. It's okay to leave it in that form. Okay, now next, we've got root 2 over 2 is the value that comes off of. That would be the y value at 45 degrees from the unit circle. So that's where that comes from. Okay, so next we need to simplify this. We're going to do that by squaring the top and the bottom. If I square the top number, we get 1. Square the bottom number, the radical goes away, and we just get 3. So far we have 1 plus 1/3. Next, we're going to square the top and bottom for here. Now, when we square that, we get a 2. Square the bottom number, we get a 4. So then this turns into 1 plus 1/3. Now, if we have this, we have 1 divided by 2/4. So if you're dividing by a fraction, you multiply by the reciprocal. So that in actuality, we have 1 times 4 over 2. Now, that's just equal to 2. So now we have 1 minus 2. We can do that first and get -1. So I have -1 plus 1/3, and then common denominators will give you -2/3. Okay, so -2/3 would be the exact answer. So remember, whenever it asks for exact value, that means that you want to make sure that you write your answer as a fraction or square roots if there are square roots. You don't want to write your answer as a decimal because that's not considered an exact answer. It's only an approximation. So moving on to the next one, for number 2 here, this is a problem where we want to draw a triangle. And we need to draw it in the correct quadrant. Now, this particular problem on version A here tells us specifically where to draw the triangle. It's between 180 and 270, and that would be in the third quadrant. Okay, third quadrant there between 180 and 270 would be right here. So for this problem, you'll need to know the right triangle definition. So I'm going to put this word down here, SOHCAHTOA. This is a word that you can use to memorize what each of these represent. Of course, you have to know how to spell it. That's the most important thing with that. But assuming you know how to spell it. Okay, so this is sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. That's what this allows you to memorize or know the trig definitions. So first thing I noticed here is I have a secant, so I don't have any of these down here. But what I can do is I can find the cosine first by knowing the fact that it's the reciprocal of this one. So the reciprocal of this is going to be -5 over the square root of 26. And I can rationalize that in a second, but I want to just use this as is for now to fill in the triangle. So now that I have cosine, cosine is adjacent over hypotenuse. Now adjacent would be, so if this is the angle, that means this would be the adjacent side here. It's right next to it. This is hypotenuse. This vertical piece, that's the opposite. It's opposite the angle. Now, when I have this here, I have negative. I actually do want to put the negative with the 5 on top there, because that's talking about a negative x-axis. So we can say that that's got a negative x value if we go to the left. And then the square root of 26 has to go on the hypotenuse. Hypotenuse is always positive. Okay, now we're missing one. Missing the vertical here, and that's going to be, we're going to use our Pythagorean theorem for that. Now the A and B, it doesn't matter, but the most important number is going to be the hypotenuse needs to go in always for C. So whenever you do these kind of problems, the longest side, or the side, you can also think of it as the side opposite the right angle, that's got to be square root of 26. Now, A and B doesn't matter, but this is the most important one, is putting the correct value in for C. So I'll put -5 in for B, and that means the only one we have left to solve for is the A here, which will be the side we're looking for. A squared plus 25 is going to equal 26. The square gets rid of the radical. Subtract 25 from both sides, and we get A squared is equal to 1. Now for this, you would need to take the square root of both sides. And remember that when you do take the square root of both sides, you get plus or minus. That's because -1 squared is 1 and 1 squared is also 1. So we actually get two different answers for this. Now we need to choose based on the quadrant we're in here. This vertical side, this is below the y-axis, or the x-axis, I should say. It's below the x-axis, which means that that's going to have to be negative here. Okay, so the opposite side is now going to be negative. So now we have our triangle complete. We're ready to now use the definitions to fill in the rest of this. Okay, so sine is opposite over hypotenuse. The opposite is -1, and the hypotenuse is the root 26. So we get -1 over root 26. Now these two things, let me go ahead and rationalize both of these. We do it the same way. We're going to multiply top and bottom by, actually, let me do it down. I'll show you the work down here because it's going to be a little bit more room for us here. I'm going to rationalize this by multiplying top and bottom by radical 26 over radical 26. You don't have to actually do this unless the instructions specifically tell you to do so. If it does say rationalize all answers, then yes, you do need to rationalize your answer. If it doesn't say that, we don't have to worry about it. So I'm just going to rationalize them anyway here. So this is root 5, then times root 26 over 26. That's going to be cosine. Now this one, if we do the same thing, I don't have enough space here to show the work on it, but it would be negative root 26 over 26, because we're just going to do the same thing, multiply top and bottom by root 26 over root 26. All right, now we have cosecant. Now I'm going to flip over the original one we have here. That's just going to be negative root 26. We can just flip this one over like that. Okay, so now tangent is going to be the opposite over the adjacent. So this is -1 over -5. Now that is going to give you positive 1/5, and we can flip that fraction and get 5 over 1 or just 5. So now we have that one complete for number 2. All right, so we have a multiple choice situation here. Choose which function best represents the trig graph below. Okay, so this one here, we have all these different answer choices. The first thing we have to do is figure out, do we have a cosine graph or do we have a sine graph? Now, probably the best way to do that is look at where the graph begins at the x value of 0. In other words, where is the graph at on my y-axis, which is this vertical axis here. So I see that the graph is actually starting above like that at that point. All right, so because it starts up here, now the difference would be if it started like, if it had something that began like this, where it went up, it went down and back. I'm not seeing that here. I'm having it goes all the way down and it goes all the way up. So if you see it go all the way down, all the way up, that's going to be considered a cosine graph. So I know that for sure my graph is going to have a cosine. So that means these sine graphs, I'm going to cross those out because I know those are no good. I know it's definitely not a sine graph. Now, how you would know it's a sine graph is, let's take a look at 3b. That's not the one we're doing right now, but it's showing you the difference there. See how down here, if I'm wherever it crosses there, I have to go up and I have to go down and back up to that. If that occurs, then you have a sine graph. So 3b will be a sine graph, but one we have right now is going to be a cosine graph because from where it starts, it goes down and it goes up. So I know for sure I can eliminate these two choices. All right, so now I know it's a cosine graph. Okay, I need to figure out from this, and if I take a look at where it starts and stops here, see how it goes a little bit past 6 right there. So if I'm thinking about this in terms of pi's, the original graph of cosine that was given in the notes was it goes between 0 and 2 pi. Well, 2 times pi is actually about 6.3-ish, somewhere around there. So I can tell that it does fit a normal period. So period on here is going to be 2 pi. Okay, so I got that. Let's take this and let's draw in. I want to draw a line that separates this graph in half. So I'm going to draw a horizontal line that separates this to where I have the equal number of boxes going up to the top of the graph and the equal number of boxes going down to the bottom of the graph. So it looks like I can draw in a dotted line at 3 there. That way I've got 4 units going up and 4 units going down. That's very important to draw that line because that's going to tell you how to find the amplitude. The amplitude is the distance from the middle of the graph all the way up to the top or the bottom of the graph, and it should be the same. That's why we're drawing this line that kind of cuts the graph exactly in half there. So I see that there's 4 units to go up and 4 units going down. That means I need to have a 4 in front of my cosine graph. So now I have this one I can now eliminate because that has a 5. That's not going to work either. All right, so now I have to have a 4 in front of the cosine. So I have that for my leftover answer choices. Now, whatever this dotted line actually is, that is actually the number that goes on the end. So in this case, I've got a +3. So you can think of the graph being shifted up 3 units. It was originally on the x-axis, but it got shifted up 3 units, which means our answer is going to have to be B. Okay, for that. So answer is B here, 4 cosine x plus 3. We just choose that one, and that is the equation for this particular graph. Next, we're going to find the distance from A to C in this figure. Okay, so that's the dotted line that we see in this figure here. This is another problem where we want to use SOHCAHTOA. We want to pick a trig function that relates to the information that's provided here. So what I want to find is this dotted line. Let's put an X there. That way we have that side labeled. So I have from 25, I'm given 25 degrees here. So now from that, I'm trying to find the opposite side, but I'm given the adjacent side. So I want to find a trig function that relates an opposite side and an adjacent side. So with my SOHCAHTOA definitions that we talked about earlier, that's going to be tangent. So we're going to do tangent 25, and now we're going to set up what it's equal to. That's going to be opposite over adjacent. Opposite is x over the adjacent, which is going to be not 50. It's going to be 50 here, not 25. So it's going to be opposite over adjacent, x over 50. Okay. From here, you can multiply both sides of the equation by 50. So if I multiply the left-hand side by 50, we get 50 tangent 25. If you multiply this side by 50, it's just going to take out the 50 you have in the bottom already. And so now our x is going to be equal to 50 times tangent 25. Make sure your calculator is in degree mode. Must be in degrees here because that's how the angle was given to you as. If you don't have it in degree mode, you're not going to get the right answer. So you got to be careful about that. When you put that into your calculator, it's going to round this to 2 decimal places. It'll tell you on the test what to round to, but this would be 23.32. And because this side is in feet, the other side has to be in feet also. So we're going to put that there. So 23.32 feet is your answer. All right, so number 5 is dealing with inverse trig. And so it says use a right triangle to write this as an algebraic expression. Now, this is important here. It says assume that x is positive. And so, I mean, so for this, that's just telling you from that, what that allows you to do is draw a triangle in the first quadrant. If x is positive, that means that everything in this quadrant's got to be positive. Okay, because this is all positive inside here. The only quadrant where everything is positive, that's always going to be the first quadrant. So these problems where you have to do an algebraic expression, you can just always draw them in the first quadrant. Inside there, this whole thing inside is like a theta, because when we take an inverse, you always get a theta for your answer. So we can say that theta equals inverse sine of x over the square root of x squared plus 4. That's really what that is telling us here, that theta equals that. Now, what I can do here is I can get rid of the inverse by applying a sine to both sides. So I'm going to take the sine of both sides. Now, when that occurs, this part that happens here means that the sine and the inverse are going to cancel. And so we get sine theta is equal to x over the square root of x squared plus 4. So in doing that, we now have a definition for sine, which means that we can label our triangle. Our theta would be here, but sine theta is equal to opposite over hypotenuse. So the opposite side from theta, opposite's going to be x, and the hypotenuse is going to be x squared plus 4. That's what this actually tells us. So this is how we can first begin by labeling the triangle by putting these in. From here, we need to use Pythagorean theorem in order to find the missing side, which is going to be this one down below. All right, so as I mentioned earlier, the C is the most important thing that you have to identify. It's the longest side of the triangle and the side opposite the right angle. So in this case, I need to put the square root of x squared plus 4. That's going to go into the right-hand side. That's the C value. And then for A, I'm just going to put in, that's the one I'm trying to find, and I'll put x in for the B. All right, so this is my equation. So I just need to simplify this. Now the square is going to get rid of the radical, which means I just get x squared plus 4 on this side. We can subtract x squared from both sides. So in fact, they actually are going to cancel out. And you get a squared equals 4. You want to take the square root of both sides. So square root is going to give you plus or minus 2. Now you have a choice on what to do, but we're already told that x is positive. That means we're in the first quadrant, which means that I'm just going to use positive 2 for that. So for these problems, you're going to work completely with the inside, and that inside is going to allow you to draw your triangle. You're going to use the outside trig function when you write your answer. So you're going to look at the triangle that's been drawn here, and you're going to use secant. Now, secant is going to be the hypotenuse over the adjacent. Hypotenuse is square root of x squared plus 4, and that's all over 2, which is going to be the adjacent. So hypotenuse over the adjacent. So that's what you would write. The square root of x squared plus 4 over 2. We don't know what x is, so your answer is just going to be this expression. Moving on to number 6. Now, number 6 is one where we have to verify the identity. Okay, so we have to know our identities on this. So for this one of the strategies that we have with these kind of problems is to change everything into sines and cosines. So that's what I'm going to do here. I'm going to change everything into sines and cosines. So I have cosine, and I'm going to multiply this by cosine, or cotangent we can write as cosine over sine. So again, we just want to change everything all into sines and cosines. So we have plus sine, and then on this side, cosecant is the same thing as 1 over sine. Okay, so now I have everything all in terms of sines and cosines. I can multiply this together. Really, this is cosine over 1. So if I multiply across the top, across the bottom, we'll get cosine squared over sine x. We have plus sine x. Really, that's over 1. And then equals 1 over sine x. Now, I purposely put a space here because we need to get common denominators next. So one of the strategies is to change everything to sines and cosines. The other strategy would be to get common denominator. All right, so I'm going to do multiply this one by a multiple of 1 here. So I'm multiplying by 1 technically. I'm trying to get common denominators on that. So I need to just do this one, sine times sine. I don't need to do that here because this one already has the common denominator we're looking for, which is sine x. So we get cosine squared x over sine x. And this is going to be sine squared x over sine x. We're going to add that together on the left-hand side. So now that we have this as common denominators, we're now able to add that together and write it over the common denominator. All right, so I have cosine squared plus sine squared all over sine x. Now this thing here, this on top, that's equal to 1. That's a special identity that you want to make sure that you know. Cosine squared plus sine squared, all that on top is equal to 1, which means that I can turn that all into 1 over sine x. And now I have both sides equal. Okay, so we've now verified that this is an identity because both sides are now equal. Number 7, we have another identity. So same thing applies here. We want to change everything into sines and cosines, and then work from there. So in this case, I think it might be easier to work with the right-hand side because the left-hand side, I could put an identity in for that. And so actually, I could do a one-step thing on that side. That's going to be a double angle on this. So 2 sine cosine is what you would put in for that, but it's about all you can really do for that side. So let's work with now the right-hand side. I'm going to change everything into sines and cosines. Cotangent is going to be cosine over sine. So I'm going to do 2. So it's really 2 over 1 and then times cosine over sine. On the bottom, I have 1 plus. This is going to be cosine. Now this, because it's squared, I'll have to do cosine squared over sine squared. So if there's no square on it, it's just cosine over sine. But whatever power you have on that, you got to put the power also down here as well. Okay, so that's what we have so far. So let's continue. We have 2 sine theta, cosine theta on the left-hand side, which we're not going to do anymore with. We're just going to leave it. And then this is going to give us 2 cosine theta over sine theta. And what I want to do on the bottom is I want to try to get some common denominators. And so I'm going to do I'm going to multiply the 1 by sine squared over sine squared. Okay, so again, I'm just multiplying by a multiple of 1. And I only have to multiply the first one because my common denominator is sine squared. So I just need it on the first fraction only. Okay, so continuing here, we have 2 sine theta cosine theta is equal to 2 cosine theta over sine theta. Now on the bottom here, we can put this together. We get sine squared theta plus cosine squared theta. All that's going to be over sine squared theta. We now have one fraction on top and one fraction on the bottom. We're allowed to now flip and multiply these. So it's going to be the top fraction multiplied by the reciprocal of the bottom fraction. So this one, we get a sine squared that's going to go on top. Now on the bottom, this here, again, that's the same thing as 1. That's the other identity we just used in the last problem. Okay, so now we're going to put a 1 down below here. So it's the reciprocal. I did take the reciprocal. It's just that I, instead of writing sine squared plus cosine squared, I put a 1 down there instead. Now we just need to do a little cleanup on this and we'll have our result. So for this, we have one of the signs will cancel with one of them up here. So we get 2 cosine theta, sine theta. Those are equal to each other. The multiplication doesn't matter here. They are both the same. So we just verified that identity. Next, it says use a sum or difference formula to fully simplify. Evaluate when possible. Okay, so for this one, the sum and difference formula that would apply here, we have a cosine with a minus. And so I'm going to write that off to the side here. Cosine x minus y, that's going to be equal to cosine x, cosine y, plus sine x, sine y. Okay, so that is the formula that you want to use here. That's the difference formula for cosine. The x is theta and the y is 3 pi over 2. So we got to plug this into the formula. So I'm just going to work with the right-hand side here of this formula. So that's going to be cosine theta in this case, because we said our x is theta. And then we have cosine of the y. Now the y is just the 3 pi over 2. We're not including the negative with it, just 3 pi over 2. And we have plus sine x, sine y. So we're going to do sine theta, sine 3 pi over 2. Okay, so we're just filling in the formula with both of those. Now it does say evaluate when possible. So we need to use unit circle for these other two here. All right, so cosine 3 pi over 2 is going to be the x value at 3 pi over 2, which is at the very bottom of the unit circle. Now that at the very bottom there, that's going to be 0. Okay, so the x value at the bottom of the unit circle is 0. Then we have plus sine theta and then sine of 3 pi over 2. Now that is equal to -1. Because again, we're talking about the very bottom. So you're at the coordinate 0, -1, the very bottom of the unit circle. X coordinate is cosine, the y coordinate is sine. So that's where we get -1 from, which means that we end up with just negative sine theta. So that's what I would put here on my blank. Okay, negative sine theta would go there. That's how we can simplify that. All right, number 9, we need to solve the trig equation. Now, if they give it to you in factored form like this, don't multiply it out. Don't do any more. It's already factored. So directly what you want to do in this case is directly set up each one equal to 0. Okay, so we're going to do that equal to 0. Sine squared theta minus 1 equals 0. If it's already factored, immediately just set each one equal to 0. You can just do that right away. Okay. Now we're going to solve for the trig functions here. So I'm going to get 2 cosine theta equals radical 3. We just add radical 3 to both sides. Divide both sides by 2. Cosine theta equals square root of 3 over 2. Okay. Now let's solve this other one over here. We're going to add 1 to both sides. Sine squared equals 1. Now because there's a square here, we have to take the square root. So if I take the square root, that'll get rid of the square there. but you have to do the square root on the other side as well, remembering that whenever you take the square root, you need to put plus or minus. That's going to be plus or minus 1. Now, a common mistake would be to put square root of 3 over 2 and 1 and negative 1 as the answers, but that's not the answers for theta. We just solve for the trig functions. So we need to use a unit circle now to get the answer. So you're going to look at the unit circle, and you want to get the, wherever you see, whatever angle gives you an x value of square root of 3 over 2. So I'm just going to go ahead and give you the answer, but you want to double check this with a unit circle. Here's the answers that you're going to get for this one. You're going to get pi over 6 and 11 pi over 6. Again, it's where the x value equals root 3 over 2 on the unit circle. So there's going to be 1 in the first quadrant and 1 in the fourth quadrant. That's where these two come from. Now for this, you can kind of think of that as doing two separate equations. Really what you're saying is sine theta equals 1, and then sine theta also equals negative 1. So you want to solve both of these individually and get the individual answers. Okay, so where sine equals 1, you're looking for the only spot on the unit circle where the y value equals 1. Now that's going to occur at pi over 2. The other one is going to occur at 3 pi over 2. That's where the y value is equal to negative 1. Okay, so these would be your 4 answers. You don't have to put them in any particular order, but it's going to be pi over 6, 11 pi over 6, pi over 2, and 3 pi over 2. Okay, so that would be that's the 4 answers you would have for this one. Okay, we know that we have to write our answer in radians because of this here. This on the end is going to tell you whether you want to write your answer in radians or degrees, so pay special attention to that one. This one's in radians, so that's why we wrote our answer that way. Number 10, which equation's graph is an ellipse? All right, so here's how you can tell what each one is. Okay, so if you have, so first thing is, if you have x squared and you have a y squared in that problem, and coefficients of them are same. Okay, so if you have an x squared and a y squared, and both the numbers in front of the x squared and the y squared are the same. If you have that, then what we have is a circle. And of course, if you have it where they're both positive, okay, so plus and plus, you have a circle. Okay, now if you have x squared, y squared, both of them are positive, and the coefficient different. Okay, so the coefficients are different. So if you have a 5 and a 7 or something like that, then what you have an ellipse. Okay, now if you have a x squared and a y squared, and you have maybe something like this, plus and minus. Okay, so if you have a minus plus or plus minus, if these are opposite signs like you have there, that means that you have a hyperbola here. Hyperbola. And then if you have only, so yeah, I'll write it this way. I'm going to put, if you have either x squared or y squared. In other words, you just have one of them only. One of them only, either 1x squared or 1y squared, you have a parabola. And then if you have x or y and x, like x and y, something like that, if you just have x and y by itself, then you actually have a line. So that's how you know what you have. So let's run through each of these, and we're going to identify what each of these have. Now, ultimately, we want to find an ellipse. So here's the first one. This one here, we have two things are squared, but as you notice, we have one positive and one negative. And so this is going to be a hyperbola. Okay, so that's not the one we want to look for here. The next one, we have an x squared, we have a y squared, and the coefficients are different. Yes, so this one is going to be an ellipse. And in fact, this is going to be the answer to this problem. But let's keep going and let's identify the other ones too for practice. Okay, now this one has a y squared and nothing else. Just one squared we have there. This is going to be a parabola. Okay, and then this one has nothing squared on it, and so this is going to be a line. Okay, so that's how you can identify all those. All right, so that is answer then is going to be B for this one because that's an ellipse. Number 11, convert rectangular into polar. Now, in order to do this, we have to know what to plug in. So we're going to do x is equal to our cosine theta and y is equal to our sine theta. Okay, so we have that. All right, so these are the two main definitions that you need to know for this. Wherever you see x squared, or an x rather, we're going to put our cosine. The y, we're going to put our sine. So let's put that in now. We're going to do our cosine theta, and that is going to be squared. And then we have our sine theta that goes after it, that equals 4. Now we're going to square both of these. So we get r squared cosine squared theta. And we have all this still is being multiplied by r sine theta. All right, so next thing, we want to multiply this together. Now I have an r squared and r squared. This is not FOIL. We're not doing this first outside, inside, last. We're not doing that here because this is all multiplication. So it's just like you're putting all these terms together. So you could rearrange this and write it out this way. So everything is being multiplied out. All right, so now that you have that, you're going to have r squared times r is r cubed. So r cubed, cosine squared, sine. There's not really much else we can do with that. Now, it does say we need to basically solve for r in terms of theta here. So we're going to solve that now for the r. Divide both sides by cosine squared sine. So r cubed is equal to 4 over cosine squared theta sine theta. Okay, and next thing is we need to take the cube root of both sides there, and because we want to get rid of the 3 that's here. So if we do the cube root, you don't have to do plus or minus here. It's only if you have an even root. So if you do square root or fourth root, something like that, that's when you have to do the plus or minus, but not here. In this case, we only have this one single answer. Now, you could leave your answer like this. I mean, you could change these into identities, but it's not necessary. And so all it's asking you for is r in terms of theta. We do have that here. So 4 over, we have cosine squared theta and then sine theta. All right, so that would complete that one. Number 12. What is the graph of the polar equation 81 tangent theta secant theta? Okay, so you have to figure out what that one is. Now, first thing, again, for this kind of problem, we're actually going to use identities first. So this problem, we've got a tangent and secant, and our definition that we just talked about in the last problem before is we basically have x equals r cosine theta, y equals r sine theta. Another one is x squared plus y squared equals r squared. So that's the other one that we have here. Okay, so unfortunately, I don't have any of that in this problem. That's why I have to work with identities first and get it into sines and cosines, so that way I could use this a little bit later. Because I want to change it first into a rectangular equation, and that way I can tell from that what it's going to be here. So first I'm going to do r equals, and then it's going to be tangent. So I'm going to change the tangent into sine over cosine. Okay, so I have 81 times sine over cosine, and then I want to change this into 1 over cosine. That's going to be the secant that we have there. We're going to put this all together. We get r is equal to 81 sine theta. On the bottom, we have cosine squared theta. All right. From here, I probably want to get rid of the fraction. So I'm going to multiply both sides of this by cosine squared. So I have r cosine squared theta. If I multiply the right-hand side by cosine squared, that's going to cancel out the cosine squared, and we get 81 sine theta. Now here, I can't make any substitutions. I can't just change this into a y because I needed to have an r sine theta to change to a y. So I don't have a y here. That would an r that allows me to do that. So what I'm going to do is I'm going to multiply the entire equation by r, and that's going to give me r squared. So I have r squared cosine squared here, and then this is going to be 81. And I'm going to put the r in front of the sine. So now I have r squared cosine squared equals 81 r sine theta. This here can be written as r cosine theta. That look a little neater here. R cosine theta, all that is going to be squared. So that's basically saying the same thing here. I have r cosine, all that squared. On this side, I have 81. This is still the same. 81 r sine theta. Okay, now this part is x that we see. I can put that in there directly. So I have x squared equals 81y. All right, so a y there. What I notice about this equation is I only have one thing that is being squared. So in that previous problem that we did before, we talked about that if you only see one of the variables being squared, that means that you're going to have a parabola. Okay, so parabola would be my answer on this. I only see one thing that's being squared here. So that's the answer. Number 13, we have this vector. We want to find the dot product, u times v. So the way the formula works here is if you've got a1, b1, and you have a2 and b2 with this, if we're actually, let me write this as multiplication here. So if I'm doing the dot products, I'll just show that. A2, B2. Okay, so if you're multiplying these two together, there's a formula that you're going to use for that. It's A1 times A2 plus B1 times B2. Okay, so that is the formula that we're going to use here in this case, with it out written this way. Okay, so I have A1, B1 here. I have A2 and B2 I can label. So u times v, the dot product, is going to be, I'm just going to fill it in. A1 times A2, it's going to be -3 times -9 plus B1 is 8 times -6. Multiply the A's together and the B's together and add them. That's it. That's how you do it. Okay, so u times v is going to equal positive 27 minus 48. Your answer is going to be -21. Okay, -21 there. Okay, so now we have the last one. The last one here, number 14. So there's going to be 14 problems total on this final exam. Okay. So we want to, the figure is drawn for us like this. So now we just want to solve for side A. And then we want the measurement of angle A. Okay, now it says write the exact value. So again, exact value means that we want to write our answer with fractions or square roots as necessary. We don't want decimals here on a problem like this. Okay, so let's start off by seeing what information is provided. Now, this is 75. We're given outside the triangle. Now, for this, we need to subtract to get the angle inside. Now, this adds up to a straight line. Okay, so if I want to find the angle inside the triangle, I'm going to do 180 minus 75. So to get this one here, I'm going to do 180 minus 75. It's 180 because this adds up to a straight line here. So if we do that and subtract that, that means that we're going to get 105 degrees inside the triangle for this. So 180 minus 75, that's where you get this one from. Now the measurement of angle A, I'll do that here. Measurement of angle A is going to be, we can find that by knowing that the sum of all the angles in triangle have to add up to 180 degrees. We already have 105 and we have a 45 in there. So you're going to take 180 again. Now, again, it's not the same meaning as 180 here. This 180 means that that's the sum of all the angles adds up to a straight line here. A straight line has an angle of 180. This time 180 represents the sum of all the angles inside a triangle. So if I'm going to do 180, I'm going to subtract 105 and subtract 45 from it. And by doing that, end up with 30 degrees left over here. So now we've just found the measurement of that is going to be 30 degrees. All right. So now if I add 30, 105, and 45, that all adds up to 180 degrees. All right. So that's the first part of it. Okay. Now, next thing we have to do is figure out the A. Now, let's see what information we're given. We really have what's going on here. We have an angle, we have a side, and we have an angle. So angle, side, angle situation that's there. Okay, so that means for something like this, that we can use the law of sines on this one. That's one of the conditions that we have. Now, to use law of sines, you have to begin with a given ratio. And we have that one right here. We have 45 degrees, and we have a side opposite that's given. So we can say that sine 45 degrees goes with the 15. So we're going to do sine 45 over 15. That's our given ratio. What we want to find is the lowercase a. Now, to find lowercase a, I need to use the angle that's opposite of a. Now, that's going to be the 30 degrees. So I'm going to do sine 30 degrees over a. Okay, so I have 45. The side opposite of that is 15. If I'm trying to solve for the a here in this picture, the angle that's opposite of that is 30 degrees. That's what I'm using here. All right, so because it gives us 45 degrees and 30 degrees, that's how we're able to get an exact value, because we're eventually we can put the values in from the unit circle. Let's cross multiply. Okay, so we're going to do a sine 45. So a sine 45, okay, is going to equal 15 times sine 30 degrees. Okay. Now we want to divide both sides and solve for a. A is equal to 15 sine of 30 all over sine 45. Now, I don't want to put this into the calculator and get decimals. I want to actually use the values from unit circle. So let's evaluate that. Sine of 30 degrees, if we use the value from the unit circle, that's going to be 1/2. It's the y value at 30 degrees. That's 1/2. And the bottom, sine 45 is square root of 2 over 2. Okay, so now we have the exact value here. If we flip and multiply, we get 15 over 2, and this gets multiplied by 2 over the square root of 2. And that allows us to be able to cancel out the 2's here. Now, what we're left with is 15 over square root of 2. Now, it doesn't mention anything about rationalizing, but go ahead and do that anyway here. Okay, so I'm going to multiply top and bottom by root 2 over root 2. And that's going to give us 15 radical 2. That's going to be all over 2 on the bottom. That is going to be the exact answer. So we have 15 root 2, all that over 2. Okay, so that would be the exact answer. So now that was all the problems on version A of the sample final exam.